Hi everyone, I would like to welcome you to this lecture. In this lecture, we will start with some foundational topics related to understanding primitives and variables in Matlab and programming in general. And so throughout the course, we will be making use of Matlab, which we introduced in our previous lecture at a high level. And so let's understand what exactly Matlab is. It's important to keep in mind that Matlab is a program that was designed for intense numerical computation. Specifically, it was originally designed to solve complicated systems of linear equations. It's considered a high-level fourth-generation programming language and contains an interactive environment that allows for visualization, numerical computation, and programming, and was the name MATLAB was originally designed or derived from the name for Matrix Laboratory. MATLAB has been expanded to make use of a number of different useful functions that allow for complex computations to be done quickly. Um, the interface can be the language and interface can be integrated and utilized with other programming languages as well. This includes C, C++, Java, Fortran, and other second generation and higher programming languages. There are numerous built-in functions and commands that can also be utilized as well. And so there are a few key components that you want to keep in mind as you work in MATLAB, and this will serve as just kind of a refresher to things that we worked on previously. That you'll have the command window, and the command window is where you can easily enter commands and get appropriate input as well as view output. You have your workspace, and the workspace is utilized in order to show the current working variables and other objects that have been created within your application or program. History can be used to show all commands that have been used in the command window. And then most importantly is the editor, which can be utilized in order to create scripts that can execute. Scripts in MATLAB can be saved as in files that can be used for execution within the application. So let's take a look again at the MATLAB environment. The most recent version of MATLAB might be R2021A or B. And again, this is the intended interactive environment. Here we have the various aspects that we just discussed. At the bottom, we have the command window where we can quickly enter and type commands. Here we have our live editor, which will display the files that we want to utilize or edit. And these could be fully functional MATLAB script files as well. Here we'll have the workspace, and the workspace will display any variables that have been utilized within our application. So if we were to use a simple, and just to give a demonstration of how the workspace operates, here we have a function for an area computation that will take as input two values, and those values will provide an appropriate output. And so if we were to execute this program, it provides us with the following error because we have not provided appropriate input. However, if we type it provides us with the appropriate answer that we're looking for. In this case, we have just inputted two values. We've inputted 10 and 20, and the function that is calculated or computed is just the area, which is the multiplication of those two values. This provides us with an answer 200 that we can utilize. This is just an overview of the functionality of Matlab. But now what we'll do is we'll further talk about some of the available commands that can be utilized in working with the Matlab environment. So now let's just take a look at some of the different commands that we can utilize in Matlab. And these are just general commands to help you on your programming journey as you improve your skill set and pick up a better understanding of how to program in Matlab. In general, you can have a few helper functions that you can utilize. These can be the help command, and with the help command, you can ask for guidance or documentation support for a specific command. You also have help when, which will open that command in a new window. You also have the doc command, which can be utilized. And also you'll have the look for command that can be utilized to look for appropriate keywords. And so, for example, if you were to run help send in MATLAB, it would provide you with a high-level overview of how the send command is utilized or sign command is utilized um, in order to provide for a computation the sign of an element. And so let's kind of take a look at how this occurs in action. So let's take a look at some of the commands that we just gave an overview of. So if we were to use the help command and enter the name of the command that we want additional insight or help on, in this case, we'll enter the sign function. If we enter this appropriately, it'll give us a little bit of information of how we can utilize this command. So in order to compute the sign of an argument in radians, we can enter sign and then the value that we want to compute. And so we could also enter this for any other function that is utilized in MATLAB. This could be, for example, the display function. It provides us with an overview of how the display function is used to print out appropriate values, as well as other descriptive information related to this utilization. We can also enter these same values, help when, in the appropriate function that we want to analyze as well. And it will open the appropriate documentation, but in a new window. So it provides for additional insight, and within this, you're able to navigate to other functions or functionality within MATLAB for a better understanding. So now let's just take a look at some other additional useful commands that can be utilized in MATLAB. We have commands like the what command that can be utilized to list all M files in your current working directory. The dir command can be utilized to list all files in the current directory as well. This would include any files outside of in files. So if you had a text file or a Word document file, this would list all of those. PWD is utilized to display the path of the current directory. And then there are additional commands like which can be utilized to display the directory path closest to a test, closest to a MATLAB script file that you're looking. So this would take as input the name of the .m file that you're looking to display that directory path for. Additional additional commands that may be utilized in order to display appropriate variables include the who command and the whos command. The who command will be used to list known variables. The whos command will list the variables, their value, as well as their size. You can use the clear command to clear appropriate variables from your workspace. as well as in the CLC command can be used to clear any information that might be in your command window. So these are just a number of auxiliary command functions that are available. So let's take a moment to go through and see each of these commands in action. So here we can take a look at some of the commands that we have previously discussed. If we wanted to see what M files are in our current directory, we can use the what command. And this provides us with a output of all of the .m files that are currently in our directory. And so this can be seen on our left-hand side as well. If we enter dir, that provides us with an overview of all of the files that are in our directory, not only .m files, but all other files as well. pwd is used to show the current directory path. So this will show the path currently for my desktop computer. We can use the which command to denote the path for .m file. And so if we do which test, it should not find anything. Yeah. But if we do which example, it displays again our current working directory as above, but it also appends that the file is there as well. Now let's say we want to list what variables are known. So if we list this, it just gives us answer, a default variable. But let's say we say something like, let's say year equals 2021. And then we display who again. Now it displays the variables answer and year. If we do the whos command, it will not only display the variable names, their size as well. Now, if we want to, and also it's important to note that these type of variables are also saved in our workspace to see what we're working with. So if we wanted to enter any other variables, so let's say if we have a variable street number, that also, as we enter it, it also gets saved into our workspace as well. Now, if we want to clear our workspace, we can type clear, and all of the variables are now gone from our workspace. And additionally, if we wanted to clear all of the data that is in our command window, if we type CLC, that clears our command windows and clean things up for us. So these are just a number of useful auxiliary functions that are available for us to utilize in Matlab. Now, as we progress throughout the course, we're going to work on understanding how to properly analyze and break down problems. And so in order to do this, what we want to do is follow what is called the 6-step process. And the 6-step process basically is a progression of different steps that will allow for us to read a problem. And when we read a problem, we're looking for specifics. We want to identify the givens, the information that the problem is telling us. We want to denote what might be the output, understand the domain knowledge, the factors that might affect the problem. And we also want to denote any assumptions that we could have about the problem as well. Next, what you would want to do is sketch a solution. And when you sketch a solution, you're basically trying to come up with a way to capture how that problem can be solved. And so a simple example would be if you wanted to uh, create a total for a grocery list, you would essentially come up with a solution that would entail just simply adding up the cost of each item on that grocery list. And you should arrive at a possible solution. Next, you want to be able to articulate the solution into a step-by-step process. And in that case, what you're wanting to do is break down what is needed to arrive at that solution. Next, the next step or the fourth step would be to translate the algorithm that you've articulated into a language that that the computer can implement, and we're implementing that through coding. The next fifth step is to test our code or test our solution and make sure that it provides for appropriate output. And the final step would be debugging, in which we identify ways in which we're able to correct any logical or syntactical errors that might be in our program or our application. And so this provides just a high-level overview of some ways in which we're able to come up with appropriate solutions when solving problems using Matlab. So now let's get started with just a few exercises so that we can practice utilizing the command window and understanding the syntax associated with working in Matlab. And so in the command window, it's very useful for us to enter quick calculations that we want to utilize in order to better understand working with Matlab. And so we can do things like enter simple expressions. And so let's say we have a simple expression. We want to take the year 2021 and we want to add 32 years to it to see what will be the year if we add 32 to it. When we click enter, it'll execute the calculation that we've entered. And so in this case, it provides us our result, which is if we, in 32 years, the year will be 2053. And so what you can do is you can approach working in the command window for any type of calculations that you want to do. So it allows for you to do any subset of mathematical operations. So let's say we want to do exponentiation. So if we say 10 raised to the fifth power, if we just enter that, our new answer is going to be 100,000. We can do other calculations as well in MATLAB. So earlier we talked about the function sine that can be used to denote a sine of an angle. So if we enter the command sine, and let's say we enter 3/5, the sine of 3/5 is in radians will be 0.5646. And it's important to remember, again, if you don't know how to make use of a function, you can always enter the help command and then the function that you want to better analyze. And it'll provide you with a brief, high-level summary of how that command can be utilized as well. It's important to also keep in mind that if you have an error in any type of calculation that you want to do, that MATLAB will also provide you with appropriate warnings. So let's say if we wanted to divide by 0. If we divide by 0, then MATLAB will attempt to do the computation. And then what it will do is provide us with the result INF, which means it's division by 0. It could be an infinite possibility. It's also important to keep in mind that we can denote appropriate end of statements without providing output by utilizing a semicolon. So let's say if we want to declare a variable like we did before, and a variable is going to represent just a artifact that will hold data for us. So when we think of a variable, we're thinking of, let's say we can have a variable for year or a variable for current year to be more accurate or precise. And current year is going to be equal to and current year can be equal to our current year, which is 2021. And so you'll notice that when we enter that, it will automatically display the output. In order to, if we wanted to not have the output displayed, we could do something like the following. So let's say we declare another variable and we say next year. Next year is going to equal to current year plus 1. And the plus 1 is denoting, of course, an additional year is plus 1. But we do a semicolon. When we do that, the computation is done and it is stored in our workspace, but it does not display in our window. And so this is a form of the syntax in Matlab that is used to hide a calculation that we don't necessarily need to display at the moment. However, if we did want to display the value, if we enter next year, it's going to output what the value is, 2022. In our first lecture, we talked about the utilization of comments. And comments are used to denote specific information about the steps or design decisions that we made in our programs. So if we wanted to denote a comment about current year, we would simply say this variable represents the current year of 2021. And you'll notice that it is in green, which means that it is only there for human information. So again, it outputs the value and that comment is there as well. Now, it's important to keep in mind that that in MATLAB, you can do whatever calculation you want. This includes addition, as we've demonstrated. It can include subtraction. So if we wanted to have a value for a previous year, and we can say current year minus 1. And the value for a previous year is 2020, which we probably all want to forget since we're getting our way through COVID, but we can't forget the past. And so MATLAB allows for us to apply common mathematical operations. And we'll get into more detail some of these different operations as we move forth. But this provides us with a high-level overview of not only working in MATLAB, declaring variables, and also applying and understanding how the MATLAB environment keeps track and allows for us to maintain the work that we've done.